Okay, looks like we're doing this video in two parts, so you don't have the middle of an announcement in there. So we had our points there, and I know the absolute value of x needs to be greater than 3. So looking at my graph here, anything greater than 3 is going to go up this way. And if it is less than -3, so if I do -5, turns it to a +5. So that's shading that line going this way. So all that changes here is I'm going to write just what I see here. So x needs to be less than -3. This is the reason being that for the absolute value, if it's down here, it becomes a negative number with a larger digit there as we go along. So less than is what we're looking for. And then x is greater than +3. And really I should have open circles there instead of just the dots. So can change that just real quick so that we've got those open circles instead of the closed dots there. Okay, doing less than. Again, we've got the same function, so that would be absolute value of x and then 3, graphing my function, and I'm sure that you already know where this is going. Put my points, there's a 3, 3, -3, 3, and to be less than 3, really I can check my 0, and 0 is less than 3, or -1 changes to a +1, which is less than 3. If I had a -5 over here, that would change to a +5, so it wouldn't be less than 3. So I can just shade that line right there and put it as I see it. So you have a -3 first, then, and I still didn't do those open dots, but there we go. So -3 is less than x, which is less than +3. And that gives me all the possible values that x could be. Okay, let's look on the back and use this to put in a couple other questions here. So I'm going to do number 5 just to look at an example with an inequality. So I have 4y1, or I guess we'll write that out first, 2x plus 8, and then a 4. So 2x plus 8, y2 is going to be 4, and let's see if we'll graph it. Oh, you know what I did not do? That should be the absolute value. I'm just ignoring it right there, so let's fix that real quick. Math, number, and then 1, absolute value of 2x plus 8. Now it'll look like it should. Okay, so we've got our function there. I'm going to draw it as I see it. My line of y equals 4. Then I'll do second, and calc or trace, 5, enter, enter, enter. That gives me my first intersection as -2, 4. And then do that again. Enter twice, but on the guess I need to move over towards this other one, and it gives me an intersection of -6, 4. Now we're looking at our at our greater than less than. So since it needs to be greater than 4, if x was a 0, say, then that would make it true, so I'm going out this way. Then if I put x as a negative 10, that would change to negative 20 plus 8, so negative 12 gives me what I need. So this is a disjunction going that way. And then all that's left to do is write it. So since it's a disjunction, I put it separate, not together. I have x is less than negative 6, or x is greater than negative 2. Okay. Last one on here would be the absolute value of five minus x. So 5 minus x, and then that's less than or equal to 11. Need to change my window here. And looks like I need to go out on my x value as well. So there's my two equations I put in. Now I'm going to copy that graph kind of as I see it. And all that's left to do, second trace 5, enter, 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 finds my first point as 16, 11. Second calc 5, enter twice, to move way over here. And that's negative 6, 11. So looking at it, that should be less than or equal to. So as I go through and figure this out, it's going to be, if I put a, let's see, if I put a 0 in here, x is 0, turns out to be 5, so that's going to be within my range here. If I put a 10 in here, 5 minus 10 gives me a negative 5, still less than or equal to that. So all that to say, I am ending up in the middle here. Then I'll just write out what I'm seeing. So I've got negative 6 is less than or equal to x, which is less than or equal to 16. And that's how we use our calculator to do some of those absolute value functions.